Good morning, chemistry students. Here is the second day of notes over Chapter 7, Section 2, the molar mass of a substance. We're going to start with a little review. Again, I would suggest that you've made yourself a little chemistry toolkit on an index card or on a little piece of paper. Because again, when you're new to doing these problems, sometimes it's helpful to look at what tools you have at your disposal to decide which tool to use. So, the other day when we talked about the number of particles in a mole, okay, you got these three conversion factors, which are counting, using the mole to count. Remember that there are three ways that we could use a mole. We can use, or three ways that we measure matter. We can measure matter by counting, we can measure matter by mass, and we can measure matter by volume. These three conversion factors here are where we are going to be measuring matter using a count. Remember to use these. It really depends on what substance you have. If you have an ionic compound, you're going to convert moles of ionic compound to formula units. You're going to know you have a molecular or an ionic compound because you have a metal and a nonmetal or a polyatomic ion in it. If you have a molecular compound, then you're going to convert molecular compound to molecules. Again, you will know you have a molecular compound because you have two nonmetals. Lastly, if your substance is an element, then you're going to, and you have a mole of it, you're going to convert it to atoms. We also talked the other day about this one, that a representative particle in the number of atoms. We talked about this with this idea that if I have one molecule of water, then I know that I have 3 atoms because I have 2 hydrogens and 1 oxygen. So you can do this, okay, with any substance, whether that's a molecule, whether that's a formula unit for an ionic compound, okay? But either one of those compounds, you could make this type of conversion factor. And again, the idea with this is I can write this as 1 molecule of water over 3 atoms when I need to do a conversion like that. Yesterday, you were introduced to the conversion factor of, okay, molar mass. This is for mass, right? 3 ways of measuring matter. Counting, which we have here, mass, which we're talking about now, and then tomorrow we'll talk about volume. So this conversion factor has a special name. Its special name is molar mass, and 1 mole of a substance is some number of grams of substance. This comes from adding up the atomic masses on the periodic table. Remember, to be able to get an accurate molar mass, you have to have correctly written your chemical formula for your ionic or molecular compound. Okay, so that's kind of a review of what we've talked about so far and what you should have on your chemistry toolkit that you've made yourself. So today we're going to start by kind of picking up where we left off. Remember, we ended yesterday, you guys calculated the molar mass of water and of glucose. Okay, so we can use the molar mass of an element or compound to convert between the mass of a substance and the moles of the substance. Again, by using the term substance, what we are talking about here then is that this could be an ionic compound. This could be a molecular compound, or this could be an element, okay? So it's just generic. It's just saying whatever kind of substance you have, whether that substance is an ionic compound because it's made of a metal and a nonmetal or has a polyatomic ion in it. Whether that substance is a molecular compound because it's made of two nonmetals, or if that substance is an element, okay? Any which one of those, you can use this molar mass to convert, okay? Convert means we're going to be talking about doing some math problems, okay, between the mass of a substance and the moles of a substance. So again, that gives us this conversion factor, which is molar mass, that we just kind of reviewed, but again, we're just going to kind of put it again in our notes, okay? Some number of grams of a substance over 1 mole of that same substance. And again, remember, the power of these conversion factors is that I can put my units wherever I need them to be. So if I need grams to be in the denominator, I can do that. And again, where do these numbers come from? These are from our periodic table. We're going to add up the masses of our elements on our periodic table to get these numbers that go in front of grams. So that brings us to a problem. We're actually going to do 2 problems. Our first problem is, what is the mass in grams of 9.45 moles of aluminum oxide? Well, one of the first things that we're going to need is we need to be able to write the formula for aluminum oxide. So aluminum oxide, that's a metal and a nonmetal, so that's an ionic compound. So remember, our steps for writing the formulas for an ionic compound are symbols, charges, crisscross, lowest whole number ratio. So my symbol for aluminum is Al. It has a charge of +3 because it's in group 3A. Oxide is O, -2 because it's in group 6A, and so I crisscross down and I have Al2O3. So again, even though this is only one sentence, I like to summarize what it's asking me to do. So it's asking me to take 9.45 moles of my aluminum oxide and figure out how many grams of aluminum oxide I have. Again, this helps me because this tells me that this is my given that I have to start with. So I always start with my given in my problem, which is 9.45 moles of aluminum oxide. Now, moles need to be on the bottom, so that means I'm going to use this conversion factor right here. So I'm going to put 1 mole of aluminum oxide and some number of grams of aluminum oxide. Now, how do I get that number? So for aluminum oxide, I have aluminum and oxygen. I have 2 aluminums and 3 oxygens. Boy, I'm struggling to say aluminum today. Okay. Aluminum's mass from your periodic table is 26.982. Oxygen is 15.999. Again, what I'm showing you right now, this is not work that you're required to show me. I'm showing this for the people who are still struggling with where do we get these numbers from. So 53.964. 47.997, and I'm going to add these 2 numbers together, which gives me a mass of 101.961. So I'm going to put that number in here. Okay, so moles of aluminum oxide are canceling out. So I'm left with the units I want, so that makes sense. So I'm going to multiply those numbers together because they're both in the numerator. Okay, and I should have 3 sig figs because the problem gives me 3 sig figs. So with 3 significant figures, your answer is going to be 964 grams of aluminum oxide. Again, this is pretty easy to put in your calculator. I think everybody knows how to do this because there's no scientific notation required here. Okay, but it's just 9.45 times 101.961 should give you your answer. I know I'm multiplying because this number is in the numerator and this number is in the numerator. Okay, so there's our first problem. And again, here's our answer here. All right, our second problem. How many moles of iron 3 oxide are contained in 92.2 grams of pure iron 3 oxide? Again, first thing I need here is a chemical formula. Iron 3 oxide, that's a metal and a nonmetal, so I'm going to do symbols, charges, crisscross, lowest whole number ratio. So iron is Fe, has a charge of +3, that's what the Roman numeral is telling me. Oxide is O, -2, so I have Fe2O3. Again, this problem is asking me to take 92.2 grams of iron 3 oxide and figure out how many moles of iron 3 oxide that is. So again, this kind of helps me out because that's my given that I'm going to start with. So I'm starting with 92.2 grams of iron 2 oxide. Grams are in the numerator, which means grams have to be in the denominator now. And moles are going to be on the top. This is my molar mass conversion factor that I'm using. Okay, so that's this one back here again, but this time notice I'm using this one because I need grams to be in the denominator so that it will cross out. Again, the numbers here, okay, grams are going to cross out. Moles is always the easiest number because it's 1. To get this number, again, I have to use my periodic table. I have iron and oxygen. I have 2 irons. I have 3 oxygens, which is still going to be 47.997. It's not going to have changed. Iron is 55.845. And I have 2 of them. And again, I'm going to add these 2 numbers together. Again, this isn't work you're required to show, but again, I'm showing it so that people who are still kind of struggling to make sure they're calculating their molar mass correctly can see. So now this is the number that goes in this problem. Now, this time I have to do division because 92.2 is in my numerator, and I'm going to divide it by my denominator. And again, I have 3 sig figs, so my answer needs to have 3 significant figures. So you should get about 0.577 moles, we have to have units, of iron 3 oxide. So this is our answer. Again, this work you don't have to show. Okay, I'm just showing it so you know where these numbers come from. Most people can do that on their calculators without a problem. Okay, so that is our second problem, and that brings us to the end of the notes for today. Again, you don't have any homework, so it's a good time to make sure you're caught up in chemistry class. Also, you could use this time to make sure you're caught up in all of your other classes that you have. Have a good day, and I will talk to you tomorrow.